So apparently, circles have theorems. Today we'll be having a look at every circle theorem and trying to solve all of them. But before looking at anything, first make sure you know these terms. We get a circle. We plot a dot in the middle called the center. If we draw a straight line that touches the 2 points at the circumference and the center, we get a diameter. If we draw a straight line that only touches 1 point of the circumference and the center, it is a radius. The perimeter of the circle is known as the circumference. If we draw 2 radii, the area in between the 2 radii is known as the sector, and the part of the circumference between the 2 radii is the arc. If we draw a random straight line that touches 2 points at the circumference but does not go through the center, it is a chord. The area between the chord and the circumference will be called the segment. And if we draw a line that outside of the area of the circle but touches the circumference of the circle at any one point, it is called a tangent. Take a few seconds to understand this, then we'll move on. So circle theorems. We start with the easier ones first. If we draw a tangent and draw a radius from the point where the tangent touches the circumference, the angle between the radius and the tangent will always be 90 degrees. Unfortunately, this is too easy for a proof to exist. The tangent only touches 1 point of the circle, and for that point to extend to reach the center, the line basically has to be perpendicular to the tangent. It doesn't matter what direction the tangent is going towards the circle, as long as it touches, this theorem works. Before we continue any further, if you find this content to be useful, make sure to subscribe and support us. So second one, if you draw a diameter, then extend 2 lines from the edge of each circumference of the diameter to touch at a certain point, the angle between those 2 lines will always be 90 degrees. In concise terms, you can say angle in a semicircle is 90 degrees. Get ready for the proof of this, yes? Label the points A, B, C and O as the center. Draw an extra line from O to B. We know that AO, BO and CO are all radii of the circle, meaning that they have the same length. As the rule for an isosceles triangle is for 2 of its sides to be the same length, triangle ABO and BCO are isosceles triangles. Knowing that base angles of an isosceles triangle are the same, within triangle ABO, angle OAB and angle OBA are the same size, and angle OBC and angle OCB are also the same size. Label angle OAB and angle OBA as X. Label angle OBC and angle OCB as Y. X and Y can be the same but can also be different. We know that the sum of 3 angles within a triangle add up to 180 degrees. Therefore, after labeling, we can find angle AOB to be 180 minus 2x and angle BOC to be 180 minus 2y. We also know that an angle on a straight line is 180 degrees. As angle AOB and angle BOC makes up angle O, which is on a straight line, the size of angle AOB and angle BOC sums up to 180. If we substitute our values in, 180 minus 2x plus 180 minus 2y equals 180. Rearranging this, we get 2x plus 2y equals 180. Looking back to the angle we are concerned about, angle ABC is made up of angle OBA and angle OBC. Angle OBA has a size of x, and angle OBC has a size of y, meaning angle ABC has an angle size of x plus y. We know 2x plus 2y equals 180. Dividing both sides by 2, we get x plus y equals 90 degrees. This, therefore, proves the theorem. Long day, I know that, but there's a chance this comes up in the actual exams. One more before ending. If we draw a point far away from the circle, then extend the point with 2 tangents that touches the circle. The length of the tangents from its initial point and the point touching the circle are the same. For precision, lengths of tangents from a point to circle are equal should do. To prove this, we just have to use the congruency of triangles. Firstly, draw a line from the center to the initial point of the tangent. Label points A, B, C and O as the center. Now we should get triangle ABO and triangle BCO. We prove these 2 triangles to be congruent. AB and AC will be the same length. So firstly, draw the radii from point A to O and from point C to O. These 2 have the same length as radii of a circle is always the same. We also know that angle OAB and angle OCB are both 90 degrees due to the theory we talked about before. And for the finale, OB is shared between the 2 triangles. These 2 triangles are a right-angled triangle. We found that the length of the hypotenuse of the triangle are the same. One more side of the triangle is the same, and there is a right angle. Therefore, due to RHS, both triangles are congruent, and the 2 tangents do have the same length. This is it for this video, but this is not the end of circle theorems. Next video will clear up this mess, but for now, do remember to subscribe and I will see you on the next time.